Namaste, welcome to the second video we have today. That is starting from the point where we stopped in the last video. That is in uniform circular motion, speed, angular velocity, kinetic energy, angular momentum remains constant in uniform circular motion. If the motion is uniform circular motion, if the circular motion is uniform, which is uniform circular motion in which speed will be constant, angular velocity will be constant, kinetic energy and angular momentum will be constant, and linear velocity, momentum and acceleration change, which are changing quantities: linear velocity, momentum and acceleration. Okay, now one more point you have to remember in this is about centrifugal force. It is also known as fictitious force or pseudo force. Is the force acting away from the center. Its direction is away from the center, so it is actually in the direction in which opposite to the it is opposite to the direction of centripetal force. Okay, so what is the equation for centrifugal force? Means that is same as centripetal force, same one. So you can see the equation here: F equal to mv into omega, not w, omega, equal to m omega square r equal to mv square by r. You can refer the terms in from the last video. I have explained what are those things. Now today's important topic, that is work, energy and power. Work, energy and power. In brief, what and all we have to remember is the first point, that is when a force displaces a particle, then work is said to be done. In physics, when we say work is done, when a particle is displaced by a force. See, this is a particle that I have placed on the book. I am giving a push, means I am applying force, so it displaces, changes its position, so work is done here, work is done. Okay, so that work done, W equal to Fs cos theta. F is force, S is displacement, theta is angle between F and S. Work done equal to change in energy. The relation between work done and energy is work done equal to change in energy. If there is a work done, there will be change in energy. Work done is zero when and all work done becomes zero. When F is zero, force is zero, means this W will be zero. Similarly, when S is zero, S means displacement. When this displacement is zero, this what you call work done will be zero. Then when F and S are perpendicular to each other, F is perpendicular to S, then that means this theta, angle between them, will be 90 degrees. So circular motion is that case. You remember in the last video we have discussed. In this case also cos 90, it is zero, right? So W, this work done, will be zero there, right? Coming to the next point, work done is scalar. You know, two types of physical quantities that we know for the time being: scalars and vectors. There is other one, tensor. You don't know about that now, so no need also. We will see about that in the future classes if possible. Work is scalar. SI unit is joule. Work's SI unit is joule, represented by J. Dimension is M L square T to the power 2. Okay. Next. What next? That is rate of doing work is power. Rate of doing work is Power. What is power? Three things we have seen: work, energy, and power. Now power, rate of doing work is power. SI unit of power, that is watt. Watt is SI unit of power, that is watt. Power equal to work by time, that is rate of doing work. What is the meaning of that? If I need to write an equation for that, that will be power equal to work by time, or it is FV. F is force, V is velocity, FV. Okay, power is scalar. Its dimension is given here, ml square t to the power minus 3. You can get it. So here it's ml square t to the power minus 2. Okay, minus 2 is what? Dimension of work. Just to change it, ml square t to the power minus 2. And that of power is ml square t to the power minus 3. Energy is capacity to do work. Yes, once again, energy is capacity to do work. Energy is scalar quantity. SI unit is joule. These things you have to remember. Again, dimension of that is ml square t to the power minus 2, as that of work. You know, works dimension is ml square t to the power minus 2. Similarly, that of energy is also same. That is why you say work done equal to change in energy. Their dimensions also same, their units also same, joule, right? So that is important. The relation between kilowatt hour and joule, two units. 1 kilowatt hour equal to 3.6 into 10 to the power 6 joules. Remember this relation. Now, potential energy of a particle of mass m at height h from ground is given by EP equal to mgh. What is m? Mass. G, acceleration due to gravity. H, height. Suppose if I hold an object at a height h, if it is an object, height from this point to, or from ground level to this point, that is height h. Acceleration due to gravity will be acting on it. So what is the potential energy at this point? That is mgh. Okay. Now kinetic energy, other part. Kinetic energy of a body of mass m moving with a velocity v is Ek equal to half mv square. Very familiar equation for you. From high school onwards you are studying about that. So no need to explain about this. Very clearly you can remember it. Half mv square, m mass, v is velocity. Okay, momentum. What is momentum? P equal to m into v, or P equal to root of 2m Ek. M is mass, Ek is kinetic energy. The relation between P and Ek, obviously Ek from this is equal to P square by 2m. Okay, this relation, or this relation between P and Ek is very important for solving some problems in competitive examinations. Maybe P given what is kinetic energy, may be asked, or Ek will be given what is momentum, may be asked. So you have to remember these two relations. Okay, important relations for finding answers for some trickier questions. Very easy if you remember the relation. It seems very easy, but you may not be remembering at the point when you have to remember. Yes, next is potential energy of a spring, EP equal to half kx square, or it is equal to half Fx. K is force constant, x is displacement of the spring, and F is force here. Okay, force. remember this equation also. This is exclusively for a spring, displaced spring. Now, if a body of mass m is to be displaced on an inclined plane of a inclined plane to a distance of x, amount of work done. So you know what is the shape of inclined plane? This is the shape of inclined plane. This is plane. This is inclined plane. Okay. What is the thing is, this is, if it is inclined plane, what you have to do? You have to displace an object from here to here of mass m. So what you have to do? You have to do some work. You are displacing it. That work done is given by mg sin theta x. Mg sin theta x. X is displacement. Mg, m is mass, g is acceleration due to gravity, theta is the angle, that is angle between this mg and the x. Mg is actually a force, x is displacement, mg sin theta is a vertical component of mg. Those things, if I explain more, it will be difficult to remember. So if you want to see that, you can refer your some books where you can see it. W equal to mg sin theta x. For the time being, as I am making this video very simple, remember this equation. Remember this equation may be directly asked somewhere. If I explain it by taking the components and all, it will be a little difficult. So for the time being, just remember this equation. If you want, you can say in the comment. I will make a separate video on that. About 10 minutes I'll explain it. Don't worry. If you want, I will put the video. Okay, now conservative forces. What are conservative forces? Are the forces where work done by these forces, work done by which will be independent of path. Path independent forces, that are conservative forces. The forces which do work, those works are independent of path. Examples: gravitational force, electric force. These things you have studied in your theory part, so I will not explain as theory. For the time being, just remember example: gravitational force and electric force. Yes, non-conservative forces are those work done by which depends on path. Opposite to this. Okay, opposite to this. Example: frictional force, viscous force. Question may be asked like this for competitive examinations, that is, a gravitational force is conservative force, non-conservative force. We can't say none of the above. So what we have to choose? Gravitational force is a conservative force. Similarly for these forces. So remember examples, main examples I have quoted, 2 examples to each, and I have found some questions directly like that, so I have included examples, these two here, these two here. So 4 important examples, remember. Okay, got it? Yes.